Hello and welcome to Donovan Evans Tutoring. I'm your host, Donovan Evans, and we're continuing it with the series where I'm completing at least one question for you per day. Looks like today we're going to be reviewing some stuff in terms of combining like terms. So a little bit of an algebra review. Let's get right into it. So here we have the terms. It looks like we want to combine. We see some terms that look kind of similar. We're not using x, we're using p for our variable. We see some exponents and we see something that doesn't have a variable with it. So in terms of organizing our thoughts, in terms of digging into our academic toolkit, what is the definition of like terms? How do we know if something would be considered a like terms? So a good definition that we can run with is that like terms are represented algebraic terms that have the exact same variable part raised to the same exponents, right? So again, same variable and same exponent. So we want to take that into consideration whenever we're reviewing to determine can we add and subtract, right? Now, usually for this conversation for combining like terms, I want to note and highlight what we're really talking about is adding and subtracting, multiplying and dividing across variables, or within the same variables. That's going to take on a little bit different context, and we go over that in maybe some other problems in other videos. But for now, what we're saying is if we're going to combine like terms as expressed here, what we're most likely doing, we're going to be doing some sort of addition or subtraction, right? So let's keep that in mind. Now, my recommendation is just a pro tip. If you're going to combine like terms, I might recommend that you evaluate and underline so that you can make sure A, you found all the terms that are similar and that would be considered like terms for each step, and B, to make sure that you aren't including anybody that shouldn't be in the group. So I'm going to make sure I do that for sure on this run. So let's take a look here. We have a 7p squared, right, and then minus 3p. So if I'm going to start off with the p squared, my first thought is that 3p, we're not going to be able to add and subtract that to the p squared because we have a different exponent there, right? And just for reference, when we look at that 3p, I'm going to underline that just for emphasis right now. When I'm looking at that 3p, would I say that that has an exponent of 0 or 1? Hopefully you said that you recognize that we have an exponent of 1. So just because we don't see that exponent there does not mean that it does not exist. So we want to keep that in mind as we move forward, okay? So 7p squared, what else looks similar to that and has a like term with that? It looks like we can say just that 2p squared. What I would recommend, even as we're considering what we're going to combine, I would go ahead and rearrange so that the items that I'm considering like terms are next to each other, right? So now I've rewritten this expression so that my p squares are next to each other. And after I account for them down below, I'll go ahead and cross them out, all right? Similar strategy in terms of this next variable set, right? So in terms of negative 3p, we'll say plus 5p. Are there any other variable, any other terms rather, that have p alone or have p raised to the first power? Nope. So we got the whole gang here. So let me go ahead and write that down. And that accounts for them, again, being next to each other, just to make our lives a little bit easier, right? And then we can say minus 1. That is the only number from the original expression, right? Okay, so last step, or hopefully the last step. What we want to recognize now in terms of combining, as I said before, if I'm mentioning combining like terms, I'm really leaning into addition and subtraction. So I see here I have 7p squared plus 2p squared. If I'm thinking about what they're asking, if it's addition, then I'm really going to just be adding those coefficients since I already have the like terms next to each other. So it's going to be 9p squared. Please forgive my handwriting. And then we're also going to go ahead, and I can cross those out now that I've already completed that part of the operation. And now I have negative 3p plus 5p, right? Nothing else to account for there. So I have a negative 3 plus 5p. Hopefully we can recognize that if I'm doing minus 3 plus 5, There may be some that say, hey, isn't that a -8 or isn't that a +8? But we need to remember that this is a real quick lesson within a lesson. On my number line, if I have a -3 here and I want to add 5 to that, what I'm really saying is that I'm moving 5 spaces to the right. So I want to make sure I always account for 0 if I can. So I want to move 5 spaces to the right. So it's going to be 1, 2, 3, 4, 5, landing me at a +2 as my answer. Just a real quick lesson within a lesson. So we have +2, P, and then -1, since there isn't anybody to subtract that 1 with, right? So this is the simplified expression. Hopefully that makes sense. Hopefully it wasn't too fast. Hopefully it follows, and hopefully you're able to understand. So that's going to be it for today. Thank you, as always, for tuning in. If you can, please like, follow, and share on TikTok, YouTube, and Instagram. Of course, my website is here. If you have any questions, feel free to contact me. If you need any help, feel free to give me a ring. Happy to help. Hope all is well. Have a great one.